Hello, I'm Rob Higuerita, and I'm a Principal Technical Account Manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. And joining me today is Akash and Aiden from AWS Support. Can you give us a quick introduction, Akash, and then Aiden?
Sure, Rob. Hello, everyone. My name is Akash, and I work as a solutions architect. And I help customers in implementing serverless architectures on AWS. And today, I'm excited to share my experiences because I think this is a wonderful technology that is making builders more productive. Over to you, Aidan.
Thanks, Akash. Good morning. My name is Aiden. I'm an enterprise support lead based in San Jose, California. And I'm also glad to share my experience in serverless architecting to help you get started today. And looking forward to this talk today.
Great, thanks for the introductions. As they mentioned today, we're going to be talking about AWS serverless architectures and specifically focusing on those best practices on architecting for serverless and moving away from the classic three-tier architecture on servers. But before we get into the details, a quick note to the attendees online. Please feel free to use the chat window on the right-hand side of your screen to share your thoughts and ask your questions throughout the episode today. We really look forward to hearing from you and getting some questions from you for our experts this morning. So Aiden, can you go ahead and get us started on what we're going to be talking about today?
Yes, so we'll cover the basics of serverless, really, how to get from like a classic three-tier architecture, as you mentioned, to more, say, serverless patterns like event-driven architectures, etc. And we'll dive deep into three major services to help you accomplish this. This is AWS Lambda, Amazon API Gateway, and Amazon DynamoDB. And we'll cap it off with how to really get started in serverless, how to start developing, how to start implementing these serverless architectures, followed by Q&A. So Akash, over to you to kick us off.
Sure. Thanks, Aidan. Okay, so let me start with a very standard three-tier architecture. And it has been a cornerstone architecture pattern for decades and remains a popular pattern for user-facing applications. So you have a presentation layer. It can be a mobile or a web application. And then you have a logic tier where you will write your business logic. And then you have the data tier where your databases will run. Very standard three-tier architecture. But when it goes to production, this is how it looks like. So your web layer becomes have many servers, right? And they are in auto scaling group. And then you need a load balancer to balance the load for web servers. And similarly, you would need servers for application servers managing application, and then you will have load balancer for again balancing load for those business logic. And then you will have database under primary and secondary setup. And then you would have CloudFront for caching requirements at the edge, and you will have static information in S3, and then you will use definitely Route 53 for your DNS resolution. So a standard three-tier architecture become a complex deployment involving multiple components, right? And if you see this architecture, there is one thing which is common across multiple layers, and it is servers. And servers are really powerful. And with great power comes great responsibility. And what are those responsibility? Let's look at that. So from a developer perspective, if I have a server, I would want to know what is the operating system of the server, where it has been whether it has the application server I intended to use is there, and whether it's IIS or JBoss is installed in that machine. From an operations perspective, I would want to know how many servers I need for production for average and peak load, and what is the right size of the server, and how to patch them regularly, when to scale out. From a security point of view, I would want to know who has access to the servers. Is antivirus installed? How to control access? So you can start imagining, right, from a developer, operations, security, and from a cost perspective, you want to right size the server. So there are so many questions you have to answer when there is a server. And according to a survey, CIO says that 80% of developers' time is spent on operations and maintenance of application, and only 20% of time is actually spent on innovation. Now, with this, imagine how much effort goes into undifferentiated heavy lifting. So, what should we do now? And the solution is serverless. Right? Let's understand what is serverless. So, a service is called serverless when there is no infrastructure provisioning and management required. So these are the 4 dimensions, right? One is you don't require any infrastructure provisioning, no management. It should scale automatically based on the volume coming to the service. So you don't kind of provision the infrastructure for scaling. It scales automatically. Third, it is highly available by default. So your service is spans across multi-AZ, and you don't kind of do it manually or by through any process. This service has inherent capability to scale across AZs, and you pay for value. So you pay only for what you use. So these are the 4 dimensions you look at when you say service is a serverless service. And we will dive deep into a few of the services. Coming to the AWS operational responsibility models, and if you see here, uh, you have the freedom of using virtual machine when you have full control, to using something like Amazon EC2, where you spin up virtual machines within seconds, and then to Lambda, which is completely serverless. And with this capability, your operational responsibility decreases when you go from left to right. And the choice whether to use EC2 versus Lambda or RDS versus DynamoDB would depend on what kind of workload you are building and what kind of management you want for that workload. So there is nothing right or wrong. It is all about choosing the right tool for the right job. And you can see how your kind of management overhead comes into picture when you use these kind of services and what kind of control you need. So I will quickly kind of stop for a question. Are there any questions, Rob?
Hey, Kosh, thanks. So no questions right now from the audience. So I'll go ahead and let you continue on. But audience, please make sure to post your questions here for Akash and Aiden. Thank you.
Sure. Thank you. Moving on. Most of the time, I've seen people feel that serverless is only about compute, but it's not about that. So Lambda is one service which I'm going to cover, is ephemeral compute, and but then we have services as part of storage. So, for example, Amazon S3. For if you use Amazon S3, you go and store a file, and you don't worry about how that file is stored and what is the storage layer behind it, how that is managed. It's completely abstracted from you. So you focus mainly on uploading the file, and the rest things are taken care by Amazon S3. So great example of a serverless service. Similarly, Amazon API Gateway, right? When you use Amazon API Gateway, you kind of upload the Swagger file and put the API specifications on API Gateway, and don't worry about the scalability of API Gateway. It is taken care automatically, and Aiden will cover more that in detail. So we have services from compute to storage to integrations, covering serverless spectrum. Moving on, let me talk about Lambda first. So AWS Lambda is our serverless compute service where you focus on writing code and don't worry about how it is getting deployed in a runtime environment. Right? So let's see how it works. So when you write a function, you choose a language, whether it's Node, Python, Java, C Sharp. We support most of the popular languages. And if the language support is not there, you can bring your own runtime as well. And we also support container images with Lambda now. So a lot of flexibility in terms of how you want to write code using Lambda. And then there are 2 ways you can call a function, either asynchronously or synchronously, right? So you can directly call a Lambda API synchronously and run the function, or function can be attached to a event. So you could say, when I upload a file onto S3, I want to process that file. So when a file is uploaded, you can map function to the event, and that function will process the file for you. So both ways are possible. And then you have in the function, you can kind of write into another database, or you can call another service. So the way you write your normal programming, you can do with Lambda function. So now with the basic definition of Lambda function, let's see what are the unique characteristics of a Lambda function. So it supports up to 10 GB of RAM. And what does that mean? With 10 GB, you get 6 vCPUs. So whatever RAM you choose, you get proportional vCPU for your function runtime environment. And you can the function can execute for 15-minute duration. maximum, and you can upload artifacts up till 10 GB of size for images, and then you have 512 MB of temporary storage available with the function itself. And from a security perspective, we can define who can call this function and what this function can do. So you can say, I want to just call, I want to just write to DynamoDB. So you can give very restrictive access to function so that it doesn't go and write to other databases. And then this function have a ephemeral worker environment. What does it mean is, if there is no request coming in, we take away the runtime environment. So you don't pay any charges if there are no requests coming. And with that, the application which should run on with these functions should be stateless. And that's how we scale faster, because we don't have to manage state and we kind of spin up multiple Lambda runtime environments. But if you need to have a session state, we recommend you kind of use out of the proc session state, either using DynamoDB or any other mechanism, which is not part of the your runtime environment. Lambda function also supports elastic file system. Very useful feature when you want to process large files, or you want to have larger libraries which you want to embed into the function. You can mount the file system and use those libraries, or you can use it for processing large files as well across multiple functions. And finally, you pay per invocation and for runtime duration. So you don't pay for idle time. Any questions so far?
Hey, Akash, thanks. We do have one question here that came in from the audience from Spagno Tony. They had a question on what's the difference between Lambda and Fargate in the context of serverless.
So Lambda gives you, I mean, from a Fargate perspective, Fargate is more towards making containers serverless. So when you spin up containers, we have to worry about managing containers in EC2 instances and managing the worker environment. With Fargate, you don't worry about that, and you kind of configure the number of vCPUs needed for that container, and then Fargate takes care of spinning those containers. And Lambda and Fargate both are serverless technology. When to use what? Lambda have a limitation of 15-minute duration. Fargate doesn't have, because Fargate is more about orchestrating containers in a serverless manner. So you can execute any code beyond 15-minute duration. So if you have if you have a process which is running more than 15 minutes of duration, you could use containers using Fargate in a serverless manner. And if you have a process which requires real-time interaction and completes within 15 minutes, then Lambda can be used for as a serverless technology.
Great. Thanks, Akash. Appreciate the info about the two. Back over to you to continue.
Yeah. Now, the first question customers ask me is, okay, how do I size my runtime environment? Because your function is depending on the memory allocated to the function. So how do you define what is the right size memory for the function? And if you see this graph, so 3.5 seconds were taken for a function with 128 MB of RAM. But when I increase the RAM to 1.5 GB, response time becomes 250 milliseconds. So it's drastically reduced when I increase the RAM. And if you see the cost, it is slightly reduced. I mean, it is not increased when you increase the memory size. It was few pennies, and then it is further reduced by 10-15%. So it is not like that if you use a function with higher memory, it will be more expensive than a lower memory. You need to find a sweet spot between memory and your function execution time. And we have tools like Lambda power tuning tools. There's a link available, and you can use that to find out what is the sweet spot for your function, and that can save you cost in terms of finding out what is the right configuration for your function. Finally, coming to tracing and monitoring. So from a tracing perspective, most of the time you would be using Lambda along with other AWS services, and you would like to understand the entire path of the call coming from API gateway to Lambda to other services. And you would like to find out, are there any bottlenecks in the path? And that's where X-ray comes in. So X-ray has a background process that runs within Lambda function and keeps sending segment information about the Lambda function to access service, where a service map is created and which can which covers, okay, the request has come from API gateway to Lambda to another service, so that you can see the complete traceability of the request. And that's where Xray can be very helpful to implement observability kind of objectives. And a function should also have a structured logging. It helps in easier searching and aggregating, and that's where you can use, again, there are Lambda power tools available from AWS Labs, how to kind of structure your logs so that they are easily searchable. Again, I mean, we can share the links with you so that you do structured logging as part of your function, as part of best practices. And then you have the custom metrics also using CloudWatch logs. So what CloudWatch embedded metric format, EMF, does it, you can send high cardinality metrics as part of EMF to CloudWatch logs, and there also you can create alerts on those metrics. And finally, we also support open telemetry using Lambda layers. So you can kind of bring in those kind of, I mean, Lambda layers, and then integrate with the open telemetry specifications. And we also support third-party kind of tool support as well as part of the logging and monitoring. So with that, let me move to a demo. Okay, can you see my screen? Okay, so this is the AWS Management Console. Those of you who are seeing it for the first time, and we have 200 plus services. We have services under compute, under machine learning, and then I mean, there are others as well from analytics perspective. But Lambda comes under compute. So let me go to the service, and this is the Lambda dashboard, where you see how many functions I have, what is storage they are using, and what is the concurrency limit per region. That is 1,000 for me. So now let me create the function. So when I create the function, there are 4 options when you create a Lambda function. One is author from scratch. You can use a blueprint where there are predefined functions. For example, getting an object using Python language, you can choose that and export that function and use it. You can also use container image by giving the ECR, Elastic Container Registry URI, and then saying what architecture it supports. And finally, you can use our serverless app repository, where we have thousands of examples of from third-party developers, which you can leverage. For example, here there's Alexa skill kit on fact skill, and there are 100K deployments. So you can reuse that and build on top of it as well. So yeah, so let me start with author from scratch. I will give function name here, and then I'll choose the runtime available. And it can be .NET Core, Go, Java, and then you can use your custom runtime as well. And then you have to choose whether it is x86 or ARM architecture, and then you have to choose what permissions you want to give to Lambda. And it starts with very basic permissions to CloudWatch logs, but then you can change the role to whatever you are looking for. You can do that. And finally, under advanced settings, you can do code signing, or you can enable the network to run Lambda functions under a VPC. So I've already created this function, so I will not create it, and I will go back and show you how it looks like. So this is a function where you can see there are 8 lines of code, and you can upload a new function using a zip file or using a S3 location. So both are possible. So now let me go and change this code and show you how I can test this function using the console. So I will change the text here, save it, and then deploy it. And I will create a new test event. I will keep it empty. So I will just give a name and then I will keep it empty right now and then create the test event. And I will test it. So you can see it has printed the new text. And below, if you see, there are logs from the function where it says how much time it took, 3.3 milliseconds. And what is the billing duration? So Lambda is billed per millisecond. So yeah, it's for 4 milliseconds it is billed. And if you see, the size was 128 MB and the memory usage is 53 MB. So it gives all those kind of details. So let's show you some other things as well. And under configuration, you can change the memory size till 10 GB, and you can also change, yeah, here you can change the timeout as well, and you can change the role. And yeah, very important, triggers. So when you add trigger, you can say from which event function should be called. So you can choose, let's say, API gateway. So when a call comes to API gateway, you want to invoke a Lambda function, you can do that. So API gateway event is available, and you can see there are multiple services available. So let me show you S3. So under S3, you could choose what events. I mean, you can choose on the put, post, event types, and then kind of attach your function mapping, and it will call that. Under permissions, this is more about what function can do. So right now you can see it has a very basic permission only to CloudWatch logs, but you can change the role and then it will have more permissions as well. And as part of destination, what this does is when your function is called either asynchronous, if there is a failure or success, you can say the function can kind of put details into the SNS topic or SKS queue without you writing a single line of code. So automatically, and the details will go to this topic or queue on failure of the function or on success. So this is a new feature which was launched, and very beneficial if you have you want to kind of automate those failures and success. You can have environment variables kind of added. You can be leveraged as part of the function code. You need to tag it. You can attach a VPC. I mean, where Lambda can run under a VPC. And finally, let's talk about monitoring and operations. So under monitoring, from an observability perspective, metrics, logs, and traces, right? So under metrics, you could see how many invocations of the functions have happened, what is the duration of the function, how much time it is taking, error count, throttles, right? Concurrent executions of the function. It gives all those kind of matrices, which is helpful in terms of understanding how your function is behaving. And then under logs, it will just tell you the log streams of how that function is executed. And then if you have put any logs, it will show those logs here. And traces is more around X-ray, which we have not enabled here, but then yeah, you can see the entire service map. So this was on console. Let me move to the IDE. So I'm using Visual Studio Code. You can install AWS plugin for Visual Studio Code. And when you install plugin and configure it, you can see the regions available as part of your access key and secret key. So I have to, if I go under Lambda and refresh it, I will have the new function here. And from here itself, I can upload the function. So as a developer, you can do that. And there is another way using SAM, which is a serverless application model. It's an open source framework for building serverless applications. And what it gives is you to install a SAM client, and then what it gives you is kind of a environment where you can test your function locally without going to AWS. So you can debug, test your function locally using SAM local. And then once you are ready, then you can go ahead and deploy it on AWS. So you can save so much of time in your local development environment and then kind of deploy it on AWS. So that was a quick demo of how you can do it on console and on through your IDE. So, are there any questions for me?
Hey, Kosh, thanks for that information. So do you have a question for the audience? And I have a question myself, too. Does AWS Lambda support thread and processes and environment variables? Is kind of what you were going through there?
Yes, very good question. So Lambda allows you to use normal language and operating system features such as creating additional threads. and processes, and you can launch processes using any language supported by Amazon Linux. So yeah, that's possible.
Okay, great. And then I do have a question from the audience from Mr. Builder 10. Mr. Builder 10 is wondering, can you automate serverless deployments in Lambda and Fargate?
Sorry, can you come again? What is the
Yeah.
question?
Can you automate serverless deployments in Lambda or Fargate?
So, how do, okay, so the question is, how do I automate serverless deployments? And that is
Yes.
possible. That is possible through serverless application model. So you can write construct using serverless application model in terms of, okay, I have an event, I want to map my function. All this can be written under serverless application model. And through that, and what it serverless application model does, it kind of, the same templates convert your code into CloudFormation template behind the scene and run it on AWS. So you can completely automate your deployment of serverless infrastructure using SAM. And there are other kind of frameworks also available like serverless for Lambda.
Thanks, Gosh. I'll post a link into the chat about the AWS serverless access model for that. Back over to you.
Yeah, let me share my screen.
So Akash, while we're grabbing that screen, there was something in your demo that piqued my interest. I noticed you had in your runtime configuration a setting for architecture, and that's actually quite a new feature to choose from either x86 or ARM architecture, and brand new feature. So we've talked about Graviton 2 in the past. Similarly, on Lambda, you can run your code and with ARM, and that gives you up to 34% better price performance. So new feature, wanted to call that out last few weeks here, and that should just be very straightforward if you have the packages that are supported there, and you can even run that change from your Docker files. So yeah, good stuff. Thanks, Akash. Let me jump into the rest of the architecture here. So let's talk Amazon API Gateway, right? Um, API Gateway acts as the front door for your applications to access data, business logic, functionality from your backend services, right? Such as workloads running on the code running on your AWS Lambda function, right? Or any web application or any real-time communication apps. So this is the front door, right? And when I say, APIs are the front door of microservices, like by microservices, I really mean they're an architectural and organizational approach to software development where software is composed of small, independent services that communicate over really well-defined APIs. And we'll dive into this here. So the real benefits really of API Gateway, there's 6, we could talk about here. And some of these are more familiar to folks than others, right? Being fully managed, to have automatic scaling, just to pay for each request. We've seen this. These are very similar benefits to what Lambda gives you, like resiliency. For example, API Gateway gives you the resiliency across routing over multiple availability zones. You don't need to worry about that for API Gateway. That's fully managed, and you really pay for only what you use there. And there's tiered pricing as well. The more you do use it, the lower your pricing gets, etc. So this is really friendly in an event-driven and API-driven architecture. You pay for exactly what you use. 2, it supports really popular protocols such as HTTP, REST, and WebSocket. And I'll cover that in the next slide. What are the major differences there? 3, native connectivity to really key AWS services, like Lambda is a great integration, WAF, Web Application Firewall, X-Ray for tracing and observability, which you covered in your demo a little bit. And 4, API Gateway can be entirely private. It doesn't need to be over public access. This can be for your own VPCs, your virtual private clouds. And, for example, internal APIs, if you have compliance needs, you don't need to expose your endpoints externally. 5, this is customizable. API Gateway is customizable. So, for example, if you have your own authorization and authentication needs, you can do your own custom authorization for yourself. And that's great. It's not just a a set and forget. You can actually customize and have Lambda authorizers, etc. And 6, you mentioned this before, Swagger support. So you can use your own Swagger API definitions. If you want to import your Swagger API definitions, we have an open source tool for this as well. So it's very easy to keep your really well-defined APIs and actually modify and update them through API Gateway. So let's dive into that number 2 there. Really types of APIs, right? Like supported protocols here. There's 3 major protocols supported. There's HTTP APIs, REST APIs, and on the right, WebSocket APIs. And under the umbrella of RESTful is the HTTP and REST APIs. On the left, both HTTP and REST APIs are meant for short-lived communications. This is like, your request response pairs, such as standard HTTP methods like get, post, put, delete, etc. These are stateless, meaning your client is sending a request to a service and the service is responding synchronously back to the client. So this is a great use case for, like web applications like a message board, or you want to do a bank transfer. These are also highly cacheable requests and quite, resilient to network errors, being stateless. On the right, and I will cover a little bit more how to choose between HTTP and REST, but on the right, really quickly here, WebSocket APIs open the door to richer bidirectional communication where clients can push data simultaneously. And keeping the connection open allows you to avoid overhead of reestablishing that connection, right? If you want to build, say, a really high frequency traffic service with small payloads, that's a great use case for, like chat apps or multiplayer games, right? Or a trading platform, for example. So just back to compare to help you choose between, one slide back for a moment here, just to help you choose between HTTP and REST APIs. The real difference here is HTTP APIs are very lightweight and lower cost. But the trade-off here, like REST APIs are very feature rich with a lot of AWS integrations. So if you need to integrate to say AWS WAF, you'll be choosing the REST option, right? So feature rich versus like very, very lightweight and low latency with HTTP. And we can paste a comparison of both of these here. So wondering, any questions from the chat, Rob, at this point?
Hey, thanks, Aiden. No questions from the audience, so audience, please make sure to post your questions here. But I do have a question. So you talked about HTTP and API and WebSockets, but what if we want to use GraphQL APIs? Does AWS have a recommendation on serverless usage with GraphQL?
Yeah, Rob. So we have a service specifically built around to service this. This is AWS AppSync. And that's a great use case, like a lot of mobile use cases, GraphQL, to do multiple requests at once, to query multiple sources. It's very optimized for that. So I would definitely recommend looking at AppSync for GraphQL.
Great, thanks, Aiden. I'll go ahead and post a link then to AppSync in our chat as well, but back over to you.
Thanks. So let's actually talk architecture for, like, what does an architecture diagram look like with API Gateway, with Lambda here. And first and foremost, right, let's break this diagram down here, all the way from the client all the way to the backend server. And first of all, there's 3 API endpoint types with API Gateway. There's edge optimized on the top here, there's regional, and then there's private at the bottom. And you'll choose the type based on where the majority of your API traffic originates from. And on the top, we have the most diverse option here, really. If an edge optimized API endpoint is the default option for API Gateway, for REST APIs, and it's the best for really distributed, especially geographically. And API requests are routed to the nearest CloudFront point of presence. That's a POP in our docs, and this automatically gives you a fully managed CloudFront distribution. So over 100 plus point of presence you could use there globally. The next major one is if you are intending to service clients from the same region, and this is the regional API endpoint. So for example, you have a client running a Lambda function that calls an API in the same region, or an API is intended to serve a smaller number of clients with really high demands. A regional API reduces that connection overhead, right? And this is in through your own customer managed CloudFront distribution, right? And lastly, at the bottom here, applications and services, running say in a VPC, a VPC that say you own, for example, your own backend services, and this is basically where you can have an interface, a VPC endpoint, which is created in your VPC, and that can be a private communication channel just for your own API. This is really it's best if you have internal APIs or compliance needs for that. Next, once your request gets into API Gateway to be processed, here's what we're dealing with. We have, first and foremost, at the top, you can actually have that immediate caching from the CloudFront distribution I mentioned. And if you're using a REST option, this allows you to actually cache and improve your endpoint's response time. So you can basically reduce the number of calls made to your endpoint, and then improve your latency and reduce the traffic to your backend services as well, if you're able to just give the common answers for your requests. And at the bottom, we're seeing CloudWatch monitoring. What is that really giving us? So that is giving us all your important metrics of, say, how many 5xx, how many errors, or 4xx errors, how much data did I transfer? The most important things about your traffic that you really care about here. Am I having errors in my backend? What's my success ratios? What's my latency? Are customers getting great response times from my total end-to-end requests here? So lastly, once we're talking with the backend here, first and foremost, perfect use case for API gateways with Lambda functions. We can integrate seamlessly with Lambda and have our responses there. You can have public endpoints off of EC2 instances as well, or any other AWS service really responding. Even you can reach out to other publicly accessible endpoints if you do need to enrich data from other sources. And in the bottom right, in the green box here, we can actually have endpoints in VPCs, or even using AWS Direct Connect, like a private line to, say, an on-premises data center. And that's totally a very, very proper response pattern you can have with API gateways. So yeah, good stuff. So Rob, do we have any questions from the chat here?
Thanks. I don't have any questions right now from the audience, so I'll let you continue on. Appreciate it.
For sure. So let's talk authorization, authentication just for a moment here. So there's 4 major types of authorization here. And this is even more undifferentiated heavy lifting that API Gateway can take care of. And first and foremost, when you can have a totally open authentication here. So if you don't want to, if it's a very public service anyways, that makes total sense to not need further authentication. You can have IAM, identity and access management permissions. Like, if you have there's 2 parts to that: having your developers and your administrators be authenticated properly to edit your API definitions, as well to have, say, IAM roles to grant access to to access your APIs, right? So that you can have humans and you can have machines authenticated there. The third point, Amazon Cognito. This is a separate service which is fully managed and has great integrations to API Gateway. This you can have, user pools with thousands or millions of users properly authenticated and scoped for API gateway. And lastly, if you want custom use cases here, like for Lambda authentication, Lambda authorizers, you can use Lambda, like write a Lambda function to have third-party authentication, and this is for your own separate access here. So custom usage is definitely an option as well through Lambda functions. Perfect. So here we go, DynamoDB. Let's talk the data tier for a moment here. DynamoDB is our, for any scale, fast and flexible NoSQL database service. And, it's designed to handle performance at scale. Millions of requests per second is possible. You do not have to worry about, partitioning separately, handling your own distributed data store. You don't need to worry about the servers, the underlying servers here, patching, what I mean, scaling them separately. So really, really straightforward capacity management through DynamoDB. This lends itself to be a really great fit for serverless architecture. And, and when you're ready to take it to production and enterprise use cases, it's giving you your keys really here, like encryption at rest, point-in-time backups, very easy to use workbench, exporting data to S3 as well. So this is a great use case for a super fast NoSQL key value database at any scale here. Let me pause here for a second. Do we have any questions from the audience here, Rob?
Hi, and we do have a couple questions that came in here. So one that came in from Ray_DB222. Welcome back, Ray. Can I build a serverless app on Flask with Lambda?
Yes, Flask. So this is the Python backend, I believe, right? So Akash, did you want to handle this one as the Lambda expert?
So if customers are building microservices using Flask, then definitely Lambda can be used for Flask. I'm running Flask application. So I just want to give that, add more points to that question.
Great, thanks, Akash. Appreciate that. And I just have one other question too that came in from Cloud Crawler. Will you all be explaining cores as well in API Gateway?
Cores, I wasn't planning on explaining cores specifically, but we can cover that really briefly here. So cores is cross-origin resource sharing, and this is a very common feature to enrich your APIs here. Basically, cores setup. Do I have a quick answer for cores setup? I need to double check if cores is which I believe it is a supported feature. Cores is supported for API Gateway.
It is supported. So if the question is whether cores is supported, yes, it is supported. When you create a API, you can say cores enable, and then it would start accepting cross origin request as well. So yes, it is supported with API Gateway.
Great, thanks. And I'll post a link into the chat as well for a little bit more information on how to get started with cores and API Gateway. So back over to you all.
All right, thanks, Rob. So let's put all these pieces together. We've given you a bunch of different pieces, and we want to explain, what this really can look like together, and end to end, right? And I want to go full circle back to where we started with the 3-tier architecture, right? The first thing I want to call out here in a very simplistic architecture here, there are no load balancers. There's no auto scaling groups. There's no database replicas, or agents or servers. It's, 4 AWS services in your application code here, right? Let's say we have an AngularJS, web app where the UI, is in S3 along with the other HTML, CSS, static contents, right? When your users download and render this, their requests will hit the API gateway. which will be routed to the right Lambda functions and run the business logic like your standard CRUD, create, read, update, delete, operations that make most apps tick, right? And lastly, you can store and retrieve all of your, say your user data, session data, et cetera, app settings from, very resilient, scaled DynamoDB tables, right? And the big key here to me is, you don't have to worry about any of the other load balancing and auto scaling groups or replicas. You just worry about the key parts of your app, like what differentiates your app really from every other app out there. And so this is really crisp and clean to me, and illustrates the major differences that Akash was talking about from 3-tier architectures when we got started in this chat. So, how do you get started really? Like, what are the options here to really get started? This is the essential toolkit, really. First and foremost, you need an AWS account in the middle here. And, the Lambda console, for example, is very user-friendly. It has, built-in development there. You can test your code as well. You can look at your error logging. You can look at your debugging, with X-ray integration as well. So a ton of tooling right in the AWS console, right from your AWS account. On the left, we have our command line interface options here, like your AWS CLIs, your cloud development kit, that's the CDK, your SAM, your serverless application models, and even, community tooling such as like Docker containers. If you are more aligned to containers and Dockers, you can just work with your Docker containers and upload that to run in Lambda. And we've got a ton of helper tools. Akash showed off the Visual Studio Code. There's a toolkit for AWS there. There's the CFN lint, the CloudFormation linting tools available. As well, we shared a bunch of Lambda power tooling to find those sweet spots mentioned, like for vCPU to memory use cases. And in fact, even we're seeing more and more workbenches, right? Like a NoSQL workbench for DynamoDB to help you write and query, optimize your queries and get the most performance out of DynamoDB. So that's the lay of the land here for getting started with serverless. And at this point, happy to take any questions from the audience.
Hey, Aiden, thanks for that last bit of information there, and Akash as well. Is there anything else specifically that you just wanted to share before we go today? Kind of covered it all already with all the different toolkits and everything, right? All right, so everyone, today we looked at how you can move from your classic 3-tier architecture using AWS serverless technologies, and also went through some of our most commonly used AWS serverless services. If there are any questions that were not answered today, you can post your questions to forums.aws.amazon.com. Please email us any feedback to awssupportsyou@amazon.com. We want to hear from you all. Tell us what else you would like to see on the show. Thank you for joining us at AWS Supports You, and happy cloud computing.
Thank you.